We all know this moment. We're playing a video game, just casually having fun, destroying some 11-year-old boy, and then he writes into the chat that he is going to DDoS us. The thing is, does he even know what a DDoS is? Do you even know what a DDoS is? Right now, I'm going to demystify DDoSing and DOSing. DDoSing is basically DOSing, but it's distributed. So DOS is a denial of service, DDoS is a distributed denial of service. And DOSing is basically just denying something from doing its usual service. And this could be quite much. And I have this analogy for you. When you are doing homework and your friend steals your pencil or annoys you and just stops you from doing your homework, he is kind of dosing you because in this moment you should be doing your homework to get better grades, but he is denying you to do your homework, so you can't really work properly at this moment. For dosing, for denying of servicing, there's actually a few examples. It could be physical, it could be just disconnecting the Ethernet cable, unplugging the power cable of your computer while you're playing video games. It could also be destroying property. For example, if I don't want to be recorded by a CCTV camera right outside of my window, I could just go there and throw a stone at it and destroy it, and it would be kind of a DOS because it couldn't do its job anymore. And also, Wi-Fi deauthentication attacks are quite common nowadays because they're actually frighteningly easy to do. So this could also be a DOS. If you're on your mobile phone just scrolling through the web or having a WhatsApp call and someone disconnects you from the internet and you maybe having no mobile data left anymore, then the call would stop because you're kicked out of the network and you don't have any Wi-Fi anymore or any network anymore. So it is a DOS. Also, there are a bunch of DOS vulnerabilities out there that are actually originating from buffer overflows or faulty or incorrect memory management inside the application, or the DOS is just caused by resource exhaustion by, for example, too many packets, or something really resource extensive is being repeated too often by too many requests or by something else. And DDoS is basically a DOS just distributed. So there are multiple parties involved, and the most common form is using botnets, because someone just managed to write a really good virus exploiting a zero-day vulnerability, and then manages to infect as many devices as possible, utilizing or gaining and farming a really big army of just bots. They don't even know it, they're just being used as bots. That's called a botnet, and this is mostly used for DDoS attacks because the botnets are actually controlled by a command and control server that is accessed by the bad guys. Yeah, obviously there's much more because he can't just easily access the C2 server. He could, but he's probably not going to do it. But that's basically how it works. And also because they are using bots, it's hard to trace back, because if you trace back a DDoS attack, you'll see lots of IP addresses. Maybe they are spoofed, probably they are going to be spoofed, so they won't even be valid IP addresses, or they will be valid IP addresses, but that's basically it. And it's really hard to trace back the originator from it. The first and the most common technique of DDoS I will talk about today is the volumetric DDoS. It's the one I think you're probably thinking about when you're talking, or when someone else is talking about DDoS. He's most likely talking about a volumetric DDoS because it's the most common one. It's also the strongest one because it's just kind of like a crowbar. You're just trying to get the server down, or trying to get it to their knees just by sending so much data to it that it can't handle it anymore. Or not only the server can't handle it anymore, but the network can't handle it anymore. It's just really a lot of data, and that's why it's measured in bits per second, because it's not about connections, it's not about the content of the data, it's just pushing this data to the target. And this actually overloads the network. So it drains the full download bandwidth of the target that can handle, for example, in my example, I used 1 gigabit per second. So if we just manage to get so many bots to send so much data that it exceeds the 1 gigabits per second, legitimate requests will be really slow because the buffer of the network for the server is completely full. This also affects all other devices behind the network because it just drains the full network connection. To mitigate this, there are a few possibilities, and the DDoS mitigation techniques are all kind of useful for all DDoS techniques, but not for all. For the volumetric DDoS, probably the most important one is just having your network data supply chain carry it for you. So basically using your internet service provider or applying an external load balancer in front of your services. So for example, your internet service provider might offer a package for you to use that includes a DDoS protection. You could also just buy a hardware appliance for DDoS protection that also includes a firewall, but mostly just is a DDoS protection configured firewall that is stateful and that might include deep package inspection depending on what kind of firewall you're using. But if you are utilizing a hardware firewall, you could just put it in front of your router and it would drop most of the packets for you. Then you could also, if you're using a hosting provider, if it's not about your Wi-Fi or your personal network, then you could also use a load balancer like Cloudflare and put it in front of your services that takes most of the garbage data that is sent to your service away from you. And also the load balancer or your hosting server itself could have the opportunity to scale the bandwidth going and coming from your server and also check the packets a bit for you. It really depends on your hosting provider. The second category of DDoS I'll discuss is the protocol DDoS. It's quite different from the volumetric DDoS because it's not about the sheer data to send. In the volumetric DDoS, we're just sending data. We're sending lots of data and that's it. That's why it's measured in bits per second. But the protocol DDoS is measured in connections per second. We're utilizing a protocol, in our case it's TCP, to do the DOS for us. Instead of targeting the whole network, so if it's your Wi-Fi, your personal Wi-Fi, in the volumetric DDoS inside of this local area network would have internet connection because your whole internet connection is drained. In a protocol DDoS, it's not targeting the full network. It's just targeting the host because the package might go through the router. They will not be dropped because of bogus data from the router. It will go through the router. It will actually have a path to go, and then it will go to your host. And there it will do its DOS. It will do its actual denial of service there. And the most common protocol attacks are SYN, flood, and fragmentation. If you're familiar with the TCP protocol, then it's quite easy to understand. Basically, the TCP protocol is a connection and stateful protocol instead of the UDP. And UDP is just sending and receiving, and there's like no checking, no checksum verification, no acknowledgement packets that the data is actually received. It is just throw and forget. But the TCP is a really good protocol if you're having reliable and consistent connections. Therefore, we need a handshake to open this connection. And the handshake is kind of shown on the left side. There is the A and the B, and for a TCP connection to start, the client or the connection initiator sends a SYN packet to the server. And then after receiving the SYN from the client, the server sends back a SYN and an ACK package. The SYN is also just stating, hey, I also want to connect with you, and the ACK, the ACK, is the acknowledgement of the connection attempt from A. And then in a full three-way TCP handshake, client A would send back an ACK. So it's SYN, SYN, ACK, ACK. Then the connection is established. But what we're doing here is a SYN flood. So basically, we're just sending lots of SYN packages to the host, to the target. Under the hood, the target keeps track on all the connections, whether they are established or they are currently being established. And as you can see here, I kind of drew it down here. There's B1, this one should be B2, B3, B4, but it's B1, I'm sorry. All of the source hosts. So each bot on this left side is sending the data. It's going to the internet service provider, then arriving at our server, at the host, And there it's going through the whole networking stack, and in the networking stack there is some kind of table that keeps track of all the connections. Here you can see it's the table and they're all in a SYN received state. This is basically the state the host is in when he just received the SYN. He will wait there. He will wait there either until the connection is fully established because they received an ACK back from the client, or they will drop the connection. They will drop the half-open connection because a timeout occurred. This is basically it, but if it's a really, really high amount of those SYN packages, this table will grow and grow and grow and grow. After some time, eventually, the table won't really allow any new connections. So real legitimate connections aren't really establishing. That's why it's the DOS attack. Yeah, it's also possible to spoof the addresses because to establish a full TCP handshake, we need to send back the ACK after, for example, the A sends the SYN ACK comes back, and then we send an ACK. In those packages, there's a lot of sequence numbers and acknowledgement numbers that all make sense if the packages are actual packages depending on each other. But if we're spoofing our source address, each package contains the address from where it's coming and to which address it is going. If we adjust or just a little bit fake the source address from where it's coming, then the server would send the SYN ACK to someone else. And this host where the SYN ACK arrives, this random IP address or this random host, doesn't know that he initiated or he wanted to initiate a connection with B. So then he doesn't send back an ACK, he sends back a reset actually. And then B just waits and waits and waits and waits. But B can't really trace back the initial packages because the source address was spoofed. So that's why the SYN flood is one of the most common protocol DDoS attacks because of this reason, because it's actually spoofable and it's not that easily traceable back. Next to the protocol DDoS, we also have the application DDoS, or mostly it's just a DOS because there is no need for a distributed denial of service, because it's not about the amount of requests, it's more about the impact of those requests. And still it's measured in requests per second, so it's not connections anymore, it's requests per second. This does not target a full host, it targets a running service. Like it's stated here, the most common attack is the HTTP flood and the slow LoRa's. Also, there are really domain-specific attacks, but they totally rely on the implementation or on the source code directly. And a mitigation for this one is actually having a stateful packet filtering firewall, because this one is the only one, and the deep packet inspection firewall. Those two are the only ones to actually look a bit deeper into the packets and filtering out strange data. Because it is normal, it is valid TCP. Those are valid TCP packets, those are valid IP packets, everything is kind of alright. It's just inside of those upper layer packets or upper layer protocol packets, there the magic happens. And these are used to overload the services and drain the services resources. For example, in the HTTP flood attack, it's just sending lots and lots of HTTP requests to the server, hoping that the server would drain. Legitimate requests are, like in the other DDoS attacks, they are just answered slowly or not at all. But this one, in the application DDoS, it just affects this one service. So if I have 5 web servers on my host, then I can put each of these web servers into its own container, having its own resource limits, and then whenever I receive this kind of DDoS attack, so this application DDoS attack is an HTTP request. For example, in our case, it's HTTP requests. So they are targeted because they are living on top of TCP, they're targeted against one direct port. So it's not about every service living on this host, it's about just one single service. Of course, if there's no resource limiting between the services or for each service, then completely overloading one service will automatically steal the resources of other services. So this might lead to the host failing as well. The application DDoS is hard to detect because the packets are completely correct. Like I said, and the TCP is correct, the IP is correct, maybe the SSL on top of the TCP is also correct. And these packages are mostly just abusing the business logic and the faulty programming. Other examples for the application DDoS include exploited or used vulnerabilities, like buffer overflows and memory corruption to just completely crash the service, and also faulty source codes. For example, if you're invoking exposed API methods a wrong way, you might get into a deadlock situation where one thread waits for the other one, but the other one is also waiting for the first one. So this might also happen. It is also a DOS because it might be blocked. Might. And what is also an application DDoS is if you take the login credentials of your friend, for example, and try to log into their Facebook accounts 20, 30 times, then at one point Facebook might completely block this user for a day or something, and then your friend cannot log in anymore. This is also a DOS. Down here I have two attacks. You already know this diagram or this visualization. This doesn't really change anymore. We have two. We have the HTTP flood, already talked about this one. It's just sending really resource-intensive HTTP requests and really much. These could be sending GET requests or sending POST requests to the server containing really much data. And they're just hoping to overload the server with the HTTP requests. Also, there's slow LoRa's attack, which sends incomplete HTTP requests, kind of like the SYN flood attack. It relies on hoping that the web server, will just wait and allocate new memory to wait until the client that sent the half HTTP request sends the other half so he can finally process this request. So the request stays somewhere in the memory until it's finished. And this could lead to an overflow or to just really extensive resource exhaustion. Now we're done with the volumetric DDoS, the protocol DDoS, and the application DDoS. Those are just categories about how the DDoS is being accomplished. Also, in the way of transmitting the packages, we could also use a reflected DDoS. And the reflected DDoS could be a volumetric and can also be a protocol-based attack, but volumetric attacks don't have to be a reflected DDoS. So reflected DDoS is basically just having a middleman somewhere in your network chain. So, for example, it needs to spoof the source IP address, or yeah, it mostly needs to spoof the source IP address. So we're sending lots of data to whatever host. In our example, it's a zombie host sitting somewhere just being accessible. So we're sending data to it with a spoofed source IP address and rely that this zombie host will respond to the packages to the source IP address, so to the actual target. This does not work with the full TCP attack or with any application-based DDoS attack utilizing any TCP protocol, because we have to rely on a full TCP connection that will not be accomplished when we're spoofing the source IP address, because then we won't be able to answer the responses to the SYN correctly. So that's why it works with the volumetric, because it's just data. We can send whatever we want. The only thing that we are interested in is that the data somehow achieves at the target, somehow arrives at the target. And we can also use a protocol-based attack, but only the half-open TCP. Now we're coming to the last one, the amplification DDoS. It's definitely not the least one because it's the most interesting one. And this one, with the mostly used example, the DNS amplification attack, heavily relies on the amplification effect. And the amplification effect is basically when the response is a multiple of the size of the request. And this utilizes a middleman and only works with spoofing the source address. So like we've already seen before, we're spoofing the source IP address. So the initial victim gets our request, responds to the request by sending the response to just a completely different host than from where the request initially came from. Here, the request is really processed. So for example, in the DNS amplification attack, we are sending a really small request to the DNS server, just querying, hey, tell me everything about you. And then the DNS response will be really big because they are actually telling us everything about the DNS server. In the DNS amplification attack, a lot of hosts, so a lot of bots inside of a botnet, for example, send DNS requests asking the DNS server to respond with everything about this DNS server. And then spoofing the source address of the request. So the DNS server starts responding to each of those requests with a really big response compared to the request and sending it to a completely different host. For example, he's sending it to the actual target. So the bandwidth usage and utilization from the perspective of the bots inside of the botnet is really small compared to the bandwidth usage by the DNS server responding to all the packages towards the target. So that's why it's called amplification attack, and this one is really, really strong. For the DNS amplification attack, the amplification factor is 50, and this is really much. So basically, if we're sending a request of 100 bits, we'll get a response of 5,000, and it's all right. Like it says, it uses UDP. UDP is the protocol for querying records from the DNS. TCP is the protocol for initializing zone transfers from the DNS. But mostly for DNS querying, we will almost always use UDP. One really nice thing, or nice, really depends on the perspective, is it's really hard to trace back, also because of this middleman. So we would need to somehow get the real IP addresses from the DNS, hopefully get the IP addresses of the bots, and then somehow trace back the request to the CNC server, and then somehow get to the actual initiator. And that could be really hard because you can access the CNC server through another bot, through another CNC, or through a Tor network. I don't really know. There's a lot of options, or VPN. You could use unloggable VPNs. Yeah, that's pretty much it. I hope you have learned quite much about the DDoS. I didn't go into so much details about basic network topology. I hope it still made sense. If you liked it, I will be posting quite much of these. I will be going into cybersecurity, I will be going into basic programming, I will be going into DevOps and microelectronics. So if you like it, please stay tuned, and bye.